So this video will show us how to use S wave function and S average wave function to collect the data from the oscilloscope to the MATLAB. And we'll see what's the difference between S wave and S average wave function. So first of all, let's set the oscilloscope waveform to occupy the screen as much as possible, as we showed in the previous video. So then we set as a normal mode by press acquire, then choose normal. So we showed this in the previous video, so you did not see in this video again. So now let's use MATLAB to collect the data. So we call V21 T21 equals S wave first channel. That's a graph. Let's cross the graph. So this is the first waveform we collected from the oscilloscope to the MATLAB. The second one, we're going to make a change. We still use S wave function. However, we're going to set the oscilloscope to be average mode. Average 8 waveforms, output the average, instead of the normal mode. So we press acquire, which we also showed in the previous video, so you could not see here again for the oscilloscope. We put the screen only for the MATLAB. Acquire, average, and we choose the average number to be 8. So that's it. Then let's collect the data use S wave again. Now we save the data with V22. So 22, 21. 21 means part 2 first step. 22 means part 2 second step. Just to help you identify when you do the data processing analysis in the lab report. T22 equals S wave again channel 1. So this is the average of 8 waveforms. But this average was done by the oscilloscope, not the MATLAB. So in the next one, we're going to show how we use S average wave mode in the MATLAB to do the average. So first of all, let's tune the oscilloscope acquire mode back into normal, because we don't want the average to be done in both oscilloscope and the MATLAB. We do an average either at the oscilloscope side or on the MATLAB side. So you can see the screen on oscilloscope, but what I'm doing is changing the average acquisition to normal acquisition. Normal. Okay, the oscilloscope side is ready. So now let's input the command. So the command, the name is slightly different. So V32 T32. Oops. Second part, step 3. V23 T223 equals S average AVG. S AVG with channel 1. So there is 2 numbers for the S average wave function. So one is channel 1 or channel 2. The other is how many times we do the average. So we do 8. its average in the MATLAB. So these numbers 1, 2, 3, 4, 5 means how many times of the data has been collected. Then we average all the 8 data sets to output the average. And cross the figure. Because we have all the data, we can do the data analysis at a later time with all these data sets in the MATLAB. So the first digit in the S wave, in the S average wave function, the first digit is channel 1. In the second digit is 8 times of average. So let's do one more similar S average wave, but instead of using 8 average, we use 25. So we learned before we can use the arrow key to get the previous input command back into the MATLAB. So 25, everything same except it's 25 average, but we do change the variable names to 24. V24, second part, step 4. T24, second part, step number 4. So this number shows how many wave output has been collected from the oscilloscope. So 17, 18, 19. It's all the way to 25. So finally it will average 25 sinusoidal wave in MATLAB, then output the figure. So let's cross the figure. So the last step in part 2 is try to collect the data with the sinusoidal wave not occupying the whole screen of the oscilloscope, but it only occupy 2 divisions of the vertical scale. So I'm operating it in the oscilloscope part. So I'm trying to tune it to occupy only 2 divisions. In 2 divisions. Takes a bit more time. Now let's try to retrieve the data again. V25, T25 equals S. So the only difference is the magnitude of this sinusoidal wave. It shrinks a little bit, but the scale also changes. So which means the real amplitude doesn't change, but it looks like it's squeezed in the vertical axis just because of the scale becomes larger. So the previous scale, it's about 0.6 volts. So now each scale, which is also one division on the oscilloscope, so it's 2 volts. It's 2.6 volts. So finally, before we end the video, let's take a quick look for the oscilloscope as well. So once I show the oscilloscope, the MATLAB screen becomes not very clear at all. So it only occupies 2 divisions on the y-axis. So that's the end for this video. Thank you.